Well, hello guys. Am I audible and visible? Aha. Hello guys. Before we go any further, I want you guys to remember the statutory warning we always do. Virus is in progress in the entire world, not just the country, the entire world. So stay safe. I've heard vaccines are on the way, but then vaccines are coming out, but they're still being tested. So vaccines tested हो रहे हैं 95% accuracy भी आ रहा है इसमें. So we have good news, but then as of now nothing is concrete. So I want you guys to stay at home, stay safe like this guy here. Be like this guy. देखो बाहर कोरोना घूम रहा है तो तुम लोग घर में आराम से बैठो and crack IIT JEE with India's largest platform, which is Unacademy right now. To get the plus subscription and access unlimited live and recorded courses from India's best educators. जो भी है इंडिया का best educators which Unacademy has right now. You can get the plus subscription using the code NSS1 to access unlimited courses from them. Get the plus subscription right away. All right. So about me, hola amigos. I am N Srikant. I did my BTech from IIT Kharagpur. I have an AIR of 385. I've been guiding young minds for the last 4+ years, 5 years. You can call it 5 years. You guys call me human calculator. Well, and I'm a Sunrisers fan, and DC is equally marvelous, if not better. I'm a big Marvel का DC का fan हूँ, Joker का big fan हूँ. So anything you like to say, hit the comment section down in the section below. All right. So this is a channel. This is a program I've launched especially for those in English. So the name of the channel is Let's Crack JEE in English. Let's crack JEE English. So this channel is exclusively for those guys who have trouble understanding Hindi or jisko English. Those guys who want English as their main language and who wants to learn in English. This is the right channel to be in. So definitely don't forget to hit the like and share, subscribe to the channel, and like this video when you see this. All right. So this is how the learning app will look. This is install the Unacademy learning app. It's pretty cool. To get unlimited number of quiz shows and live classes, which will be very helpful for you on the way to crack your exam. So today's topic we're going to be discussing is force on current carrying wire in a magnetic field. मतलब current carrying wire, if it is placed in a magnetic field, what is the force it will experience? We have like 10-15 problems on the way, and not easy ones, they're decently tough problems, along with awesome theory ahead. So this is the eighth class of magnetic effects of current. बहुत मजा आने वाला है. So stay tuned, hit the like share button so that I can understand you guys are doing it. So before we go further, just पहले we discussed about force on a moving charged particle. So we discussed force on a moving charged particle as Q into V vector cross V vector, right? This is the force on a moving charged particle. You can also write it as QVB sine phi, where where phi is the angle between velocity vector of the charge and the magnetic field. So matlab, now if you look back into it, now if you look, there is another thing, like till now we discussed this, but now we will discuss about wire. What happens in a wire? और ये एक बहुत मजेदार एक्सपेरिमेंट से डिराइव हुआ था कि when wire is placed in magnetic field, when wire is placed in a magnetic field, it will experience a deviation. It experiences a deflection. So we will discuss. काफी मजेदार है. Why? What is the force? What is the deflection it has? All these things we will be discussing in today's class. So before we go further, we have to understand what a wire is. What is a wire? मतलब wire is a place where current is flowing, right? Wire is a place where current flows. Current flow का मतलब क्या है? What is the meaning of current flow? There's a wire like this. The electrons in the wire are flowing downward. Let's say the electrons in the wire are moving downward, which means the current I is moving in the positive upward direction. So I can also be imagined as positive electrons moving along a particular direction. So you can say if electrons are moving downward, you can say positive electrons are moving, positrons both positive positrons are moving in the upward direction. So either ways you will get the same logic, but so the direction of current is opposite of direction of charge, and you observe the velocity. Electrons will have speed, right? Will have a speed which is equal to velocity drift. सबको ये पता होगा. Already we discussed in the beginning of the beginning of the sessions of magnetism, where when electrons travel through a wire, they will have a speed of drift velocity. They will not have infinite speed. They will have a speed equal to drift velocity. So each electron will now experience a force. Okay, this is the basis on which we will solve problems. Now one more thing. So इससे क्या समझ में आएगा? Current wire is a set of electrons moving with drift velocity. Okay, this is the main concept of it. A wire is a set of electrons moving with drift velocity. This is what we understand. So from this we can also say the total charge inside into drift velocity into field can be the force. All these we can actually solve. So this a force acts on when a force acts on a current through a field P. When current is zero, there is no force, but when the current is going in upward direction, is experiencing a force in this way. When the current is flowing downward, then it experiences a force in this way. So this ये काफी मजेदार चीज है. It's a very interesting concept. We will discuss about this in today's class. So now this is what I want you guys to understand. An electron is having a negative velocity downward direction and a current in the upward direction. So if the field is taken to be outward, तो Q into V cross B अगर सोचेंगे, V से ऊपर curling your hand in the upward direction, the thumb will show to the direction of force which is to the right hand side. Okay, so यहाँ पे the direction can be shown this way. So now what is the value of this? Let's find out what is the value of this. So now we know what about I, right? We know I is N into E into A into VD. ठीक है, ये बहुत लंबा फॉर्मूला है, so I won't be using this. I will simply write I is equal to charge upon time. So इससे मैं क्या लिख सकता हूँ? Q is equal to I into T. Q is the total charge which is flowing, I is the current, and T is the time it current flows. The total charge which moves Q will be equal to IT. इससे मतलब काफी simple explanation हो जाएगा. It will happen within no time. एकदम wonderful explanation से you can just get the answer right away. So what is the force on a moving charge? Force on moving charge will be equal to Q into VB, VD into T. Now charge, this Q is what? Q is the total charge which flows. Q is the charge flow, VD is the drift velocity, and T is the time. The VD velocity into B, sorry. Q VD cross B, right? This is drift speed, and this is total charge flow. And this is magnetic field. तो बस इसी से फॉर्मूला से मैं सॉल्व कर दूंगा. So what can I say? Q will be written as IT. If I write Q as IT, it will become I into T. IT into VD cross B vector. So now if you look carefully, a time is scalar, so I can multiply time with drift velocity. So इससे क्या आ जाएगा? I into VD into T. TVD or TVD cross B vector. Now what is TVD? The total length along which the electron has flown. This is nothing but the total length the electron move or current. The electron or current. Because current is taken to be positive electron. अभी हम बात किए. So current can be taken as a positive direction moving electron. So current direction I can also say a positive electron is moving along the direction of current. Okay. So total length of the electron moved will be T into VD. So this can be written as the length of the wire. Length of wire. So using both of them we can get force on a moving wire will be equal to I into L cross. Then L is the length from initial point of current to final point of egress in a given time, which is nothing but length of the wire. So length of wire is nothing. Length of wire is a scalar quantity, right? So this will not be exactly scalar. We will discuss about all this in today's class only. The length from initial point to final point. So इससे हमें I into L cross B आ जाए. एकदम अलग तरीका से टेक्निक है ये. Current direction is upward, which means the drift velocity is downward and the magnetic field emerges in the plane of the soul. So give me one moment, guys. Just एक moment दे दो. ऐसे लिखते हैं. तो यहाँ पे क्या दिखा? The current direction is upward, which means the magnetic field emerges out from the plane, causing the electrons to deflect to the right. This is the explanation of the previous. This explanation has been done here. All right. So now, so अगर इसको ऐसे ले लें, the total current. So you know Q is equal to IT, right? The Q will be equal to IT, which is equal to I into length by VD. So if you observe carefully, Q will be equal to IT, which is equal to I into L by VD. Imagine a current is flowing. Current is flowing L across L in time t. So we can say Q is IT, which is L by VD. And we also know force will be Q into VD into B sin theta. So Q में L by VD लिख दो. What is the value I am getting? The force value will get is equal to I into L cross B. So in short, in the given example, when the angle between phi and this is given, so the force will be given by ILB into sine phi. Alright, the force is given by ILB into sine phi, which can also be written as I into L cross B. And what is the direction? The direction will be given by right hand rule, right hand thumb rule. Your initial direction, you cross L cross B, you put the hand in the direction of L and you move your fingers in the direction of B, उससे हमें आ जाएगा. So यहाँ पे length इस direction में है और field is in this direction. So what is the direction in which your thumb is rotating? Your fingers are curling in the anti-clockwise rotation direction, which means the direction of field is the force will be outwards. Outwards is given by. Alright, so great explanation, guys. So if you observe carefully, when the current is flowing in this direction, this is the direction of flowing of E pluses. Electrons are flowing in this particular direction. A positive protons are, which is the direction of current, is flowing in this direction, and direction of B is given this way. So using these both, if you curl your hand in the direction of current and direction of magnetic field, you will get the direction of force to be upwards. The direction of force will be given by using this concept. You curl your hand, from length to direction of. If direction is clockwise, then force will be outward in that plane. And if it is anti-clockwise, then force will be outwards. If it is clockwise, the force will be inwards. Clear? So this is the explanation for it, guys. चलो और देखते हैं the properties of the force on a wire. Now let's look into this. The properties. One thing we know, you have to find the direction using right hand thumb rule. Or you can also you can find it using right hand thumb rule. The force will be equal to ILB sin theta. So इससे क्या आ जाएगा? Force on a magnetic field will be proportional to I. More current, more force. And it is proportional to length of the body, which is length of the wire. So ये length of the wire more है तो it will experience more force because more current, there is more charge which is moving in a wire. So we can directly say this. And it is proportional to B, which is obvious. And it is also proportional to sine phi, where phi is the angle between length and field. Okay, so this is what I want you guys to understand. The current will be proportional, the force will be proportional to the direction of the magnetic field. So इससे हमें क्या समझ में आएगा? What do we understand from this? So yes, exactly. This is what we'll get. Suppose direction of field, मान लो direction of field ऐसा है. Direction of field it's uniformly straight. मतलब यहाँ पे सब जगह B है. Suppose there is a current carrying wire like this. If the current carrying wire is like this and current is flowing in this particular direction, तो magnetic field इस direction में है और ये angle phi है, तो then we'll get ILB into sin phi. Capital है. So we'll get ILB into sin phi. Now when the angle between them is 0 degrees, when the angle between them is 0 degrees, here the force will be equal to ILB into sine 0, which is 0. So this case the body will experience no force. The current carrying wire along the direction of field. Current carrying wire along direction of field experiences no force. So ये एक बहुत मजेदार concept है. So if you are putting your wire in the direction of field, magnetic field, then you experience no force. If they both are perpendicular to each other, मान लो यहाँ पे length ऐसा है और field is still in this direction and I is in this particular direction. So this is the direction of field. So if you observe the angle between them is 90 degrees. So the force will be how much? ILB sine 90, which is equal to ILB. So the force is maximum. The force is maximum. Logical है ना क्योंकि cross product है. Maximum when theta between them or phi between them is 90 degrees. So अब से क्या आ जाएगा? 180 पे भी same आएगा. It's this way or this way. Theta is 0 or 180 degrees, you will get the same result. So from this we can say F is maximum when theta is 90 degrees or phi. And F is minimum when phi is 0 or 180 degrees. So this is what we can understand here, guys. So when at an angle theta we can get this. So it will be maximum when the angle is 90 degrees. When the angle is 90 degrees. And is minimum when the angle is along the direction of the magnetic field. So एक simple सा question है यहाँ पे. So figure shows below a current carrying wire in a uniform magnetic field. The magnetic field is directed into the page. The current direction is as drawn. Current ऐसा जा रहा है, magnetic field downward है. So select the vector drawn in the box to the right of the figure in which the direction of magnetic field. The direction of magnetic force will be what? So here if you take your hand in this direction and you're curling your hand into the page, you put your hand in the direction of current. Put your hand in the direction of the current, which is like this. ऐसे करके रख दो and curl your hand inward. Curl your hand into the direction inwards. So if you curl your hand inwards, what is the direction in which you are able to see the thumb? यहाँ पे ऐसा है और ऐसा करके और curling it, right? You are curling it in this particular direction. If you see inward, it is curling like this. So since the direction of this is anti-clockwise, you will experience a force in this particular direction. तो इससे क्या आ जाएगा? The direction of force will be around the direction of 2. Okay. So now this is another easy question. एकदम आराम सा question है. So this is the direction of B, and this is the direction of current. I is 2 amperes. The length of 2 meters is carrying a 2 ampere current is placed in a magnetic field as shown in the figure. The force on the wire is. The force on the wire can be calculated using the concept of IL cross B. which is also equal to ILB sine phi. Force will be equal to ILB sine phi. So in this case, what is the angle phi between current and this B vector? It is 30 degrees. And if you are curling your hand from current to the direction of B, what is the direction you are getting? It's clockwise, right? तो ये याद रख लेना, clockwise से क्या आंसर आएगा मैं बता दूंगा. Which will be how much magnitude will be? I is 2 amperes into length is 2 into magnetic field is 1 into sine 30 degree. What is the value of sine 30, which is 1 by 2? तो इससे सीधा आंसर आ जाएगा 2 Newton is the force. And what is the direction? Clockwise means it is inside. The direction of force will be inside the plane of paper. So always the direction of force will be perpendicular to the plane of B and I. So ऐसे ही B and I are in this plane. So the direction of force will be into the plane or outward of the plane. So यहाँ पे since it's moving clockwise, it will be into. This is an effective way of solving it, guys. Okay, next. Two parallel wires of same material and density are carrying same current are placed in a magnetic field. The ratio of their accelerations is. ये एक मजेदार क्वेश्चन है दोस्तों. So this is a very good question. You have two wires, none of the lengths are given. So what we will do is we'll take this length to be L1 and then there's a small wire having length L2. And they are placed in a magnetic field. Maybe let's take the magnetic field to be upward. Direction of a hypothetical magnetic field will be upwards. So one thing we know that mass is proportional, mass of the wire is proportional to length, right? Because mass is proportional to volume. So one thing we will say, mass is proportional to volume, which is proportional to length, because they are identical wires. So mass is proportional to length. This is first equation. All right. Second equation, what do we know about this forces? Force will be equal to I into length cross B, which can also be written as ILB into sine phi between them. In this particular case, both of them are perpendicular, so I'll just neglect this. Okay, so इससे क्या आ जाएगा? ILB आ जाएगा. So ILB sine phi में भी use कर सकते हैं. क्या ये? Whatever. So we also know force is proportional to length. I'm not even solving this problem. I know mass is proportional to length. I know force is proportional to length. So acceleration is F by m, which is proportional to L power 0. So क्या आ जाएगा? Acceleration is proportional to L power 0. From this what will we get? That acceleration will be same if current, field and phi are same. For a given wire, if everything is same like this and density, phi and density. Please take your name. Prakash Kumar Rai. Hello Ritvik Reddy, how are you? Great to have you guys. So one thing I want you guys, this is a very good question. Two parallel wires of same material and density are carrying same current placed in a magnetic field. The ratio of their accelerations is. So mass will be proportional to length because mass is volume. Mass is proportional to density into volume. So density same hai, so mass will be proportional to length. Similarly, force will be ILB. So ILB sine phi. Since they are placed parallel, phi same rahega. Since they are having in the same magnetic field, B will be same. Say they are carrying same current, I will be same. So force will be proportional to L and mass will be proportional to length. So acceleration will be proportional to L power 0. So from this you can say acceleration is same given I, B and phi and density are same for the two wires. Alright. So audio issue हो रहा है क्या? Let me see. So from this. So audio issue हो रहा है क्या? Let me see. I am able to listen to this, man. I am having a live stream right in front of me. We are able to see this. So kindly look into your internet connection. So this is a very nice funda you can also remember. Two parallel wires having same material and density. Suppose they are identical wires. The length will not matter for acceleration. Length doesn't matter for acceleration. So ये एक मजेदार concept है for a wire which we'll use as we go. The answer for this is equal to 1. All right. Now for the next question, guys, इससे हमें we'll get a very interesting concept here. Okay. Two current carrying wire of length 12 carrying current I is placed in a magnetic field as shown. Uh, in the figure, the force on the wire is. So in this particular condition, yeah, I don't know, man. I'm really not sure why very few students are here. But then we have to go. So definitely share this video, like this video, and share this video everywhere so that everyone who is interested in learning this in English can listen to this video and learn it. Okay. Live नहीं है तो क्या है मतलब the motto of this is to share this video everywhere, to reach this video to the entire world and entire country so that they can see this video and crack IIT-JEE. That is the main motto, and we are doing our work. And like Sri Krishna says in Mahabharata, do your explain the best you can and then expect nothing. So यही हो रहा है यहाँ पे. I'm expecting nothing from you guys. So I'm solving the problems on the go. So if you have any, if you are on the go and if you're solving faster than me, then definitely put it in the comment section below. All right. The wire of length 12 is carrying current I placed in a magnetic field as shown in the figure. If this length is L, it means this length will also be equal to L. So इससे दोनों का आ जाएगा. So one more thing, guys, here. One very important thing I want you guys to understand. What is the force between this length and the field? So the first point you have to understand is that the direction of length and magnetic field E are perpendicular to each other. And B are perpendicular. दिखता नहीं है ना ऐसे. It is not looking like it because I is in this plane but B is perpendicular to this plane. If you observe, length of this is along this direction and the B is inwards. B is inwards like this at 90 degrees. So now if you curl your hand, so let me explain this again. B is into the page like this. So the angle between this plane and into the page, this is into the page, will be how much? It will be 90 degrees. So now length is along this direction, B is along this direction. So if you curl your hand, you will curl your hand in this direction, and the anti-clockwise will give you the direction of force to be ऐसे. एक मिनट, इसको थोड़ा और neatly draw कर लो. Going into the page like this. The angle will be all right. So इससे दोनों के बराबर, so it will be perpendicular to this force and the direction is, it is moving in anti-clockwise direction this way. The direction of force will be upward. So इस वायर पे force कौन सा direction में लगेगा? The direction of force on this will be upwards. Do you think only watching video can crack? Envy. Prakash Rai, I really don't know what you're talking here. I know Envy sir, of course, man. Everyone knows Envy sir. I'm relatively new to this teaching firm. Envy sir is, in fact, he is one of my idols. Yes, so everyone would eventually have to start, right? Any teacher, it's not just, this message is not just for students or teachers. You have to start somewhere. It's generally for everyone. You have to start at some point. Only then can you improve and get better and eventually become the best in the field. No one starts off like, let's say Sachin Tendulkar was not better than Sunil Gavaskar when he started, but eventually he became Sachin. Cricket में ही नहीं, सब जगह ऐसे ही होता है दोस्त. So even I like to be as good as Envy sir, if not better, eventually. Let's see where it goes. This is just a starting. This is just the first step. Much long journey ahead. Just like for you guys, you are just learning it from one video. You will learn little, learn from another video. You will learn another trick from there. And eventually you will end up becoming better than many other students, which you are initially not. Okay, it's all about patience and doing well and doing the right things. So definitely hit the like button and share this video everywhere. Prakash Kumar Rai, I hope I'm helpful to you. It's not about the student, it's not about student, it's not about teacher, it's about doing the things right. It's about doing the right things. Alright. So इसमें force कितना आएगा? The force on this will be perpendicular to this in this direction using the right hand thumb rule. you will get the force to be in this particular direction. Similarly, on the second wire, so the force will again be perpendicular and it will be equal to this F in this particular direction. Both of them are perpendicular to each other. This force on this particular wire will be equal to ILB, and the force on this will also be equal to ILB in this particular direction. So the net force on the total system, the force on the wire system will be sum of both these forces, right? यहाँ पे एक force इस direction में है, given this angle is 30, यह angle कितना होगा? This angle is 60. Similarly, on this direction there is one force here. This angle is 30 and this is 90 degrees. So ये angle भी 60 degrees हो जाएगा. So the effective force are due to these both. When two equal vectors have angle theta between them, F net will be equal to 2F cos theta by 2. In this, I will substitute this here. What is the value I am getting? F net will be equal to ILB into cos of 120 degrees by 2, because the angle between them is 60 and 60, 120. तो इससे आ जाएगा ILB into cos 60 or 2ILB into cos 60 degrees, which is equal to ILB. So ये एक simple सवाल है. The answer for this is A. So इससे I will try to explain one very important concept. All right. यहाँ पे वेक्टर ऐसा है, the length is like this and the length is like this, and both of them have an angle 60 degrees between them with the direction of magnetic field this way. So what is the effective length of these both wires perpendicular to this? The effective length, इसको अगर देखा जाए तो the effective length can be written as this whole thing only. मतलब the current flowing here, if it is I and the length is 2L, it will experience same force as a body which is having I here and length equal to this, right? Because this length is L, this length is L, this length will also be L. So the force on these both is equal to the force on this wire. You getting it right? The force on these both on wire is equal to force on this particular wire. तो दोनों का force same है. From this we can get that the vector length of a current carrying wire का एक बहुत मजेदार concept आएगा. Till now we discussed length is the length of the current carrying wire, but what if the wire is curled? If wire is curled or not straight, or not a straight wire. If it's not a straight wire, we took I into L cross B, right? We took the net force to be I into L cross B. तो मतलब यहाँ पे length का एक vector होना है. If it is not a straight wire, it will not have a direction. So in this type of cases, what will you take as the total length vector? मान लो there is some current element like this. There is a current element like this. This is a current element, and current is flowing in maybe this direction. Let's take current is flowing in this direction. In this case, the effective length vector will be given by a line joining starting point of current to ending point of current. तो मतलब एकदम starting point जहां पे है वहां से start होगा and it will move to the ending point. So for this given example, this is the starting point. Current is flowing in this direction and this is the ending point. This is the place where current is moving. So you draw a line joining this to this. Now this will be the L vector for the wire. I hope you are understanding this, guys. If you understand this, definitely hit the like button. So effective current क्या होगा? कोई सा भी any wire you take, just let's take another wire like this. So this is the definition of it. This is the vector length. Or you can also say this is only L vector, length vector, और अच्छे से लिख सकते हैं. It will be defined as length vector. So any line you take, just take any wire randomly like this. What is the direction of, what is the length vector for this particular question? So the length vector will be from the starting point. यहाँ पे current ऐसा flow हो रहा है मतलब starting point to the ending point. This is the length. Got it? So and if magnetic field here is making an angle phi, so here F net on this wire and current is I. So F net on the wire will be equal to ILB sin phi. And if the length of, not the length of the wire, L is length vector's magnitude, is not length of wire. Okay, so this is the main concept you have to understand, guys. L vector, when you talk about L cross B, is the magnitude of the length vector. It is not length of the wire. चलो एक सिंपल सा क्वेश्चन कर लेते हैं इसके बारे में. A current I is flowing along this direction, radius which is forming a semicircle of radius r. Current is placed in magnetic field as shown. So what is the force on the wire? इसमें force कितना होगा on the effective wire? So this is a variable wire. So what will I do? I will simply write the effective length L vector for this. It is starting from this point because the current is flowing from this end to this that end. All right. Okay. So starting point इधर है, ending point इधर है. This is the ending point. So what is the effective length from this end to this end? It is the diameter. ये diameter है. तो L effective कितना होगा? 2r. And the direction of current is from starting to ending. तो इसके direction भी लिख सकते हो I cap. I'll solve this in vector form so that you can understand at least vectors कभी कभी. And direction of B is B into minus k cap since it's inverse. So what is the F net now? F net we can solve it. Let's see how many of you can solve it before I do. So it is equal to I into 2r I cap cross B minus k cap. तो इससे कितने आ गया? 2ir rb into I cross minus k. What is I cross minus k direction? It is equal to j using the circle loop. So we will get the answer to be 2irb in the upward direction. That's the answer, which is option C. I hope you understood this. Yes, I hope you like this. Okay, now for the next question. ये एक मजेदार question है. So a wire is in the form as shown. The net force on the wire will be. यहाँ पे current I ले लो. The current here is I, and the magnetic field here is B. This length is A. This length is B. This length is C. The radius is R, and this length is. So this is a wonderful question, guys. एकदम सीधा मल्टीप्लाई कर सकते हैं. You can just simplify the whole thing. I'm going to solve this now in a simple way. Let's see how many of you can get faster than I do. This length is A. So effective current will be just from initial point to the final point, right? So from this is the starting point of current and this is the ending point of current. So the effective length will be this vector. The direction of field is inward anyway, so we can also use that later. We can directly say I into LB. So F effective will be equal to I into L into B because L is perpendicular to B. तो यहाँ पे ऐसे सीधा आ जाएगा because nothing is clear, nothing is given properly here. Like this is in the plane and B is perpendicular to the plane. So the length vector is always perpendicular to B vector because length and B are in different planes. Hello Sairam Garu, hello Amma. Are in different planes. Alright. So from A to B, you can just write the total length to be equal to the total length of this whole circuit is what I need to find. Yo, this is how it is. So this ka length D hai, this length is here is A. This is B, this is C, and this is given as a 90 degrees. So what is the effective length between these both? It is hypotenuse minus B, right? So this will come out to be root C square minus B square. And this is nothing but the diameter which we just solved, which is equal to 2 times the radius given as 2r. So the F net now will be given by I into A plus 2r plus D plus root of C square minus square. So this into B, of course. And what is the direction of it? Use your right hand thumb rule. The direction of I is in the I cap direction and direction of field is in minus K cap. So direction of force will be in length vector is in I cap, B vector is in L cross B is I cross minus K, which is given by J cap. So the direction of force will also be equal to J cap. Alright, so great going guys. So now for a very important concept, net force on a closed loop in a uniform magnetic field. मान लो a closed loop, there is a closed loop of current. So in this, what is the starting point? What is the ending point? If you start from, there is no starting or ending points here. There is no starting or ending points here. Or in short, you can say the starting point and ending point are the same. Okay. So another way of looking at it is, you can imagine it like one current carrying wire like this and another carrying wire like this. Both of them have opposite directions of current. One will have this direction, the other will have this direction. This is L1 vector and this is L2 vector. So total L total will be equal to L1 vector plus L2 vector. We know L1 is equal to minus L2. So this is coming out to 0 vector. So the effective length is 0. The effective length of a loop in uniform magnetic field in constant B is equal to 0 vector. Hence F net will also be equal to, so from this we can say force on a closed wire will always be, in a closed loop will always be equal to zilch. तो एक example कर लेते हैं थोड़ा simple सा. What is the force on a loop like this? It's a closed loop ABCD. What is the effective field? मान लो field कुछ ऐसे direction, कोई सा भी direction ले लो. F net will be how much? Clear? Because it's a closed loop. So this is, it's as simple as this. You can also imagine another example where you can solve it like vectors. मतलब जैसे कि हम vectors में करते थे, the effective length sum of all vectors is this. Similarly, we can take any wire like this. It's a closed loop. The force, the current, let's say, is traveling this way from A, B, C, D. From A, B, C, the direction of current loop will be this one. Current vector from ABC is this and ACD is this. ADC is this. So if you take a closed loop ABCD, LABC plus LADC is the effective value, which is equal to 0. So I hope you understood this. Now tension, but ये क्या होगा? There is some different. There is the net force will be 0. ठीक है? F net will definitely be equal to 0. But what is the tension? मतलब if you observe carefully यहाँ पे in this circle, if you take a small part like this, let's take a small part here. What is the direction of current? Current is flowing outward like this. Current is flowing upward direction like this, and magnetic field is inward. So the direction of force on this will act in the outward direction. Similarly, agar bottom part if you see, direction of force will be downwards. And similarly here it will be in this particular direction and here it will be upward direction. So if you exactly like ringa roses, ringa roses, all of you do that in your turn around and play when you were kids. So that is what happens here. When current is flowing in this what direction is this? In this clockwise direction, every point will experience force. Like every person, when you're sub log, all of you are catching each other and rotating in a circle, or when you catch each other and try to pull backwards, someone is pushing you from behind, your hands will pain, right? Which means the hands will pain. Hands pain मतलब ये होता है generally when you play, which implies that tension in the hands is non-zero. Tension in hands is not equal to 0, which is exactly like tension in the string here. So this is the main theoretical concept behind it. When you play Ringa Ringa Roses, or when you are making full circle and someone is pushing you from behind, pulling you from behind, you will push both of them along with you. No? You will experience some force here. Similarly here also, just that force is uniformly applied everywhere. Everyone is feeling that force, and everyone is pulling everyone beside them closer. Matlab there will be tension in the string. Understood? I hope you can understand it. We will find out the value of tension in the string here using a very nice explanation. This is an advanced topic, mains topic, so NEET के लिए नहीं है. So those who are in NEET, you can just relax. You need not watch this video. That's what I heard. So, but then again, everywhere logic is final. So now to solve this, we have to take some small element. So what I will do is I will take a small element यहाँ पे ऐसे कुछ को. I will take double element so that I will understand better. ये angle d theta I will take, this angle also I will take d theta. So what is the total length of this? Now if I zoom into this, I will get it like this. For very small d theta, so okay, this is very small d theta. We are taking small element and solving. Small element. The radius of this is given as r, by the way. यहाँ पे radius same question है basically. Same question है. Radius r है. Current is flowing in clockwise direction equal to I. The direction of field is like. So if you observe here, what is the direction of current here? The direction of current is like this. At all points, it is perpendicular to B. I is perpendicular to B at all points. Which implies F net will simply be equal to I into L into B. तो इसमें total net effective force कितना आएगा? If you take this is almost like a straight line, ठीक है? Almost like a straight line है. तो net force will be equal to ILB in the perpendicular direction. ये जो है ऊपर ILB force. F net will be equal to I into L into B. And what is the value of length here? The length will be equal to arc length. Getting it? Which is equal to R into angle. R into 2 theta. F net कितना आया इसमें? I into 2R d theta into B, which is nothing but 2 IRB into d theta. This is the effective force on the. ये समझ में आ गया सबको? So इसका next part क्या होगा? What can we solve after this? So now if you draw the free body diagram for this, यहाँ पे ऐसा है. So एक minute, we'll draw it in the next page. Just give me one page, guys. So we can draw the same diagram again now and analyze it in a much more better way. छोटा सा angle d theta लिए, so effective force here it will be d theta. This will also be d theta. So using these both, what is the effective force here? यहाँ पे there will be tension in this direction. Similarly, there will be tension in this direction, and there is also effective F net in this particular direction. Force due to magnetic field. So ये angle कितना होगा? If you observe carefully, this angle is d theta. This angle is 90, which means this angle will also be equal to d theta, and this angle will also be equal to d theta. So now you will understand why I took d theta, because it's acting everywhere and small angles also will matter. So if you observe the net force in the upward direction, horizontal direction cancel हो जाएंगे. Tension into cos d theta, यहाँ पे tension into cos d theta इस side है. Similarly, downward direction tension into sin d theta. and this also there will be tension into sin d theta, यहाँ पे d theta, and यहाँ पे ऊपर force due to, so since the body is at rest, it is at rest because we already know the F net is 0, so we'll take the body to be at rest. So when the body is at rest, what is happening to this situation? When the body is at rest, we can say net force upward will be equal to F downwards. F up will be equal to F down in this particular direction. So what will we get? 2t sine d theta is equal to force due to magnetic field. Okay? And when d theta is tending to is very small, sin d theta can be represented approximately as d theta. यही कर दूंगा, तो इससे क्या आ जाएगा 2t d theta is equal to fb. And what is the value of fb already? Fb is already found out to be 2ir b into d theta. You can equate both of them. From equating both of them, you get 2t d theta is equal to 2ir b d theta. From this, we get tension is equal to IR. So this is the crazy explanation, guys. I hope you like this. The tension in this string will be equal to I into R into V. Yes, so great one, guys. I hope you understood. All right. So now let's talk a little about Unacademy. Crack IIT-JEE with India's largest platform, which is Unacademy. Get the plus subscription. So get the plus subscription and access unlimited live and recorded courses from India's best educators. Get the plus subscription right away and get unlimited live and recorded courses from India's best educators. Plus subscription using the code NSS1 ये मत भूलना, ठीक है? Don't forget to use this code. So what do you get with plus subscription? Plus subscription, you get access to the best of Unacademy. You get access to the best of Unacademy. So what happens in the best of Unacademy? It means you will have daily live classes. The main thing is in the app you have daily live classes where you can engage in discussions, ask your doubts and answer polls all while the class is going on. You can chat with your educator, engage in discussions, ask your doubts and answer polls all while the class is going on. Yes. Not only that, you will have live tests and quizzes where you can evaluate your preparation with regular mock tests and quizzes and get detailed analysis of your performance. What topic you're doing well, how much are you doing well, all these detailed performance will be given to you along with the daily live classes where the discussion will be dynamic. यहाँ पे there is a lot of delay between ping and the answer and the discussion. So there you will have dynamic discussions. Not only that, you will have structured courses that when you miss a class in school generally, you can never come back, you can never be as good because it is very tough for you to catch up with the classes. But in Unacademy, you will have structured courses topic by topic. Anything you missed, you can go back to the topic and read it and solve all problems which are given based on that, which will help you prepare best for the exam. Not only that, you will get unlimited access to all the teachers who are teaching in the Unacademy platform. Best teachers from South India to the best teachers of North India, everyone across the country will be available to you. So that is pretty cool, right? So what did Joker say? When you're good at something, never do it for free. That is why Unacademy is charging a nominal charge of 38,500 for 1 year. And if you use the code NSS1, it will come down to 34,650. Okay, 6 months is 28K. If you use the code NSS1, it will get down to 25.2K. So, matlab, awesome deal. Say this might sound big to see because they're 6 months and all, but then let me tell you one thing. This cost of this is 2,888 rupees per month, which is coming to 32 rupees per day on physics, chemistry, and maths. So this is the main logistic behind this. If you think about it in this way, you can really definitely go for this. You can definitely go for the plus subscription. Similarly, this is for those who want to crack JEE in 2022. Especially with the COVID situation happening so long and it is not looking clear. Those who want to crack JEE 2022, this is the best time to use the code NSS1 and get it for 50K. 50K is coming out to 23 rupees per day on physics, chemistry, maths. इससे 5-star भी नहीं मिलेगा तुम लोगों को. So definitely go for this, guys. Not only this is Unacademy is also introduced iconic subscription. This is for those guys You want to take IIT-JEE preparation to the next level using a personal coach. You can take your preparation to the next level using a personal coach. Get one-on-one guidance from top exam experts as your personal coach aligns your preparation strategy. All right. So one-on-one guidance from top examiner who will help you aligns your preparation strategy. Matlab he'll tell you what to study, what not to study. This is for those guys who need help from teachers in college, and especially those who are struggling right now because of lack of help from teachers. So the test analysis you can do where you get in-depth test analysis with personalized feedback to improve your time management. Yeah, personalized feedback भी मिल जाता है where you can work on your time management, and a personal coach along with seeing the test analysis will give you a detailed study planner which will help you study and plan accordingly. Okay, so not only this, you also get all benefits of plus. So this is pretty cool, guys. This is for those students who need help from teachers. So the cost of this is slightly more. Obviously, the first year it costs 56K. Using the code NSS1, it comes down to 50K. All right, use the code NSS1. This is the magic code. It will come down to 50K, which is coming out to 46 rupees per day. And similarly for 2022, guys, it costs 86K, but after using the code NSS1, it comes down to 77,400 only. This is 32 rupees per day again with a coach. So if you ask me, this is an awesome deal and you should go for it. So crack IIT-JEE with India's largest platform by taking the plus subscription by using the code NSS1. All right. So yes, moving on. Now magnetic field fixed है तो you can write I into L cross B. But if the magnetic field is varying across the entire wire, then you have to find force on each wire. If magnetic field is varying across wire, then F net, then F will keep changing. F will keep changing, will vary for every length. So here we will start using the concept of current element again. Here in this kind of situation, we will start using the concept of current element again. All right. So the current element vector is given by I into dl vector, right? This is I into dl. So the force on it will be given by df, the small element will be equal to I into dl vector cross b vector. So this is the concept of force on a wire due to varying magnetic field. So you have to cut a wire. So you simple cut wire into small elements. Wire into small elements. Integrate force due to source. Integrate net force. Simple. It's a very straightforward question, guys. Now let's solve a problem on this. This will so dfb will be equal to I into dl cross. So let's take a simple question like this. A wire of length 2 meters is placed in a varying magnetic field where B varies with x as B is equal to alpha x square. The force on the wire is force on the wire if alpha is equal to 4 into 10 power minus 2. And x is the distance from the beginning of the wire along the x direction. Okay, यहाँ पे x direction में along the x direction there is current. So what I will do is at a distance of L, I will take small dl element which is flowing current this way. All right. So यहाँ पे at a distance x लेता हूँ मैं because it's given in x. I will help you solve it in x. So यहाँ पे field कितना होगा? B will be equal to alpha x square. So now we can find out df will be equal to I into dl cross alpha dx. Length of this is dx, right? Dx cross alpha x square. Direction of current is this way. Direction of this is in the I cap direction. Cross alpha x square in the minus k cap direction. तो इससे आंसर सीधा आ जाएगा. I cross minus k is j, so I will directly get of I into alpha into x square dx into j cap direction. This is only equal to df. So इससे simple integration कर लो अब total force. F net vector will be equal to I into alpha into x square dx from 0 to 2. Is given by I alpha x cube by 3. newtons. This is the force acting on the particle. Now you just substitute values. Current is given by 2 amperes now. 2 amperes into alpha is given by 4 into 10 to the power minus 2 into x cube. X is given by 2. So integration of this, no, you have to integrate this from 0 to 2. That is equal to I into alpha into 2 cube minus 0 cube by 3. This is 8 I alpha by 3. तो इसमें substitute कर लो 8 into I into alpha by, this is coming out to be how much? 64 by 3 to the power minus 2, which is 0.213 newtons. So net force on the body as shown in the given particular diagram with varying field is given by 0.213 newtons in the direction of J cap. So this is a great explanation, guys. I hope you understood it. Variable field में कैसे करते हैं. Now we will discuss another special kind of variable field, where find the force on a wire of length L and current I2 placed in perpendicular to an infinite wire carrying length I1. Infinite wire है, इसमें current I1 है, so we will not take anything from here. So from this, at this particular direction, if you draw this here and the length is along this direction, that the field in this direction will be along this way. L cross. So this one you can use by using the right hand thumb rule for current. Right hand thumb rule for field. So you have to use right hand thumb rule for field. So whichever direction current is, thumb is I is in thumb, field is given by curl. So this is the concept you have to use. The curl of your hand will give you the direction of field. इसमें current ऊपर है, तो curl of your right hand will give you inward. So the field here is inward, and the value of field is given by mu naught into I1 by 2 pi a. 2 pi r, where r is the distance. R is distance. So now if you take a DL element, so यहाँ से यहाँ तक we will take a distance at a distance x. At a distance L, I will take DL element. I will just do integration in DL also, no issues. I will take a DL element. So what will the force now? DF be? DF will be equal to I into DL cross I2 है, यहाँ पे I2 है, cross mu naught I1 by 2 pi L. तो इन सबको कांस्टेंट्स को बाहर लेके आ जाओ. mu naught I1 I2 by 2 pi into DL by I, DL by L इंटीग्रेशन. तो DL by L कितना हो? ln L हो गया यहाँ पे. सो देख बस एकदम ln L वाला फंक्शन आएगा. दिस विल बी इक्वल टू mu naught into I1 into I2 by 2 pi ln L. So what is the range of L? This is the main concept you have to understand. Where is the length of the wire starting? Starting point यहाँ पे है, ending point यहाँ पे. So initial point will be A and final will be A plus L. Limits will be A to A plus L. Wire is from A to A plus L. A से A plus L लिखते, so we'll get mu naught into I1 I2 by 2 pi ln A plus L by A. So this is the force, guys. So this is how beautiful it looks. One thing you understand is it is symmetric. So if you observe carefully, it is mu naught I1 I2 by 2 pi. It is not dependent on either I1 or I2, but it's the product of both of them. Understood? So it is proportional to the product of both the currents. So you can also imagine currents just like masses. Gravitational field में product of masses था, यहाँ पे product of currents है. So alright, so abhi tak this is what we understood. Now force between two parallel, so I hope you like this. This is as complex as it can get. Now the force between two parallel current carrying wires. मतलब two current carrying wires, तो इससे clearly समझ में आ जाएगा. One wire, each wire will produce magnetic field. Each wire produces magnetic field which influences the other wire. So due to this field, due to this, the direction of field will be in this direction. If you observe, it will be like this. So यहाँ पे direction of field will be inwards. यहाँ पे it is coming outwards. यहाँ पे it is inwards. You observe the direction of current here is inward. As a result of which the force on I2 due to I1 will be in this particular direction because यहाँ पे field inward है and the direction of current is upward. So using these both, you can say the force on this will be inwards. Now similarly, the force on this direction of field due to this will be what? Direction of field due to this will be, यहाँ पे it will be outward, same logic. So here the field here due to this will be in the upward, and according to this, what is the direction of force on तो इससे सीधा क्या आ जाएगा, यहाँ पे force will also be attracted. Direction is upward and the direction of clockwise here, anti-clockwise here. So which means up and this way you will get the direction of force to be inward. So if you observe carefully, each force on each wire is towards each other. And it is also will be and one more thing you have to understand very okay. So इससे क्या समझ में आ जाएगा, these both simple सा लिख देता हूँ यहाँ पे, this you have to remember, and they both have same direction current, they attract each other. When they both have opposite direction current, they repel each other. So this is little different from the electromagnetic situation, electric field situation. When the positive and negative charges they attract, and positive and negative charges they attract, and then same charges repel. Here it's just the opposite. Same direction currents will attract, opposite direction currents will repel each other. So इसमें better explanation. So just give me one moment, guys. I am going to change this slide. थोड़ा आराम से we can. Alright, so this is it. So इससे क्या समझ में आ जाएगा? The force each wire produces V which influences the other wire. So the force on each wire is towards the other one. Alright, similarly यहाँ पे क्या होगा? यहाँ पे ऐसे ही same field होगा. So and based on this direction, the force on this will be force on I2 due to I1 will be in this particular direction. So one more thing I want you guys to understand here, the force on each wire will be proportional to magnitude of charges, will be proportional to inverse of the distance between them, and it is also equal and opposite, equal and opposite. तो यहाँ पे क्या होगा, these both forces, force on each wire forms wire due to another wire forms action reaction pair. So ये बहुत important concept है. It forms an action reaction pair. They are equal and opposite and they are caused by the same effect of electromagnetism. So this is awesome explanation for this. So मतलब अगर if you look closely, due to one the field, this is much more better explanation, but मतलब cleaner explanation. Due to one the direction of current here is out, the field is outward, the direction of field here is inward, and due to that the force on wire 2 will be inward. Force on wire 2 due to 1 will be inwards. Similarly, force on wire 1 will also be towards it. So using these both, we can say they both will have attractive force towards each other. They both will form an action reaction pair. Very cool concept. The net force on the system will be 0. So the F net on both the wires will be equal to 0. The total center of mass will not accelerate. That is very nice, one very nice way of looking at it. And similarly, यहाँ पे wire 2 magnetic field. So when they both are in opposite directions now, let this go up and this go down. The field here will be x, but the direction of current is backward, so it will experience a force in this particular direction. And both of them will experience opposite direction forces. They will repel each other. Here they will attract each other. So this is what you have to remember, guys. Same direction current will attract, opposite direction currents will repel. So now let's take the calculation of a force. So one more thing you have to understand here, when let's take calculation of force due to two parallel wires. Two parallel wires, one infinite, okay, carrying current I1, and second is finite length considered. We are only considering finite length because we know one thing. When the field is there, the force will not depend on length of the wire. The acceleration will not depend on length of the wire, but force will depend on length of the wire. So any length we take, we will end up getting the same kind of logic as a multiplier of L. So we know acceleration will be same for any length. And once we know force will be proportional to length. So that's all. We take force per unit length. So force per unit length will remain constant. Force by length will remain constant. This is what we are going to find out. Find this. So finite length current will be I2 along same direction, separated by D. What is the force per unit length on wire 2? Wire B. I'll call this B, I'll call this A. Find this force on AB, on wire B. तो इसके लिए कैसे solve करेंगे? So simple concept. The answer is we will take the field at this point when the distance is uniform from a wire. When separation is uniform, field will also be uniform because field is proportional to the aerial distance along the axis of the wire. Distance, if you go parallelly, equidistant wires will have same field. Like if you see, there will be in circles, concentric circles. So field will be same across the entire concentric circle. Everything lie at the same distance. Same distance means same field. Using this logic, what is the value of field now? Field will be equal to mu naught into I1 by 2 pi d. The first. And now what is the force on length L? Let's take force on length L. On length L. Force on wire B will be equal to I into L2 cross B. Since L2 and B are in, we know the direction, we can directly write directly inverse. And they both are perpendicular to each other. So what is the value if I apply? Which is equal to I into L2. I2. यहाँ पे कितना है? I2 है ना correct? I2 L2 into B, which is given by mu naught I1 by 2 pi d. जैसे क्या आ जाएगा? Mu naught into I1 into I2 by 2 pi d, which is also the ratio we got yesterday, into L2. This is the total force. The force per unit length will be how much? Mu naught I1 I2 . So if you also want to find the acceleration will be equal to force per unit length per density. Acceleration will be equal to mu naught I1 I2 by 2 pi d into lambda. Simple. That's simple, guys. So I hope you understood this. So now I will get into the very important part. When current is 1 ampere, when I1 is equal to I2 is equal to 1 ampere, and the separation is also 1 meter, then what is the force? F net will be equal to mu naught into I1 into I2 by 2 pi d. It is given by mu naught by 2 pi into 1 by 1. So mu naught by 2 pi का value कितना होगा? 2 into 10 to the power minus 7 newtons. So this is one of the points which is used in definition of current. For 1 ampere, it is defined as the current in two wires separated by 1 meter experience a force of 2 into 10 to the power minus 7 newton. Then the current in both wires is 1 amp. So this is the standard, matlab this is the technique which was used to measure current before before it was cool. Magnetic field के weight से you can find out the difference between the two currents. So एक comprehension type question कर लेते हैं before we go any further. 3 wires A, B, C are placed as shown in the figure. Then they answer the following question. The force on B per unit length will be. So force on B per unit length. So इसमें I will tell you one very awesome trick. Okay, I will tell you very awesome trick. So mu naught into I1 I2 by 2 pi d na. So I can also write it as 2 into 10 to the power minus 7 into I1 I2 by d. So ekdam multiply I1 I2 and divide by d and you will get the answer right away. So I will write each force on each other due to this. So first force AB and AB, force on B due to A, force on A due to B will be this way. This is FAB and this will be FBA. Similarly here it will be FBC. Since both are going in opposite direction, we can directly say this will be FBC and here it will be FCB. And if you take these both wires, they both are in opposite direction, so this will repel it with FAC. This will be FC. So each individual we can write like that. And now we will have to find force on B. If you observe force on B, both are along same direction. Both are along same direction. So we can say it will be equal to FBA plus FBC. What is the, both of them are separated by 1 meters. So FBA will be equal to 2 into 10 to the power minus 7 into I1 into I2 by 1, which is 12 into 10 to the power minus 7 newtons. Ekdam simple सा हो गया. Similarly, FBC will be equal to 2 into 10 to the power minus 7 into 4 into 3 by 1, which is how much now? 24. 24 into 10 to the power minus 7 newton. So इन दोनों को ऐड करने से कितना आ जाएगा? F net will be equal to 36 into 10 to the power minus 7 newtons, or you can also say 3.6 micronewton is the force on wire B. अब force on wire A देखते हैं. Force on wire A क्या था? It will attract due to this 3 force AB and it will repel due to force AC because they both are opposite directions. बस वही logic use करते हैं. So F total now I'll write. I will take the net direction to be positive along this direction. So इस direction ले लेते हैं. So no big. This direction F net. So F total will be equal to FAC minus FAB along the minus direction. So इसका मतलब क्या है? So what is FAC now? FAB. FAB will be how much? We already know it is equal to FBA, which is equal to 12 into 10 to the power minus 7 newton in this direction. This direction. And force on AC will be equal to 2 into 10 to the power minus 7 into I1 into I2 by D. Distance between them is 2 meters. This is very important. So इससे एक 2 cancel हो जाएगी. You will get the value to be 8 into 10 to the power minus 7 in this direction. So F effective FAB vector minus F direction. So now we know this force is stronger than this force, right? Total force on A will be equal to FAB minus FAC in the direction of FAB cap. Because FAB is greater than FAC. You observe carefully. FAB is greater than FAC. So whichever direction is there, that direction you can put unit vector and subtract the magnitude of it. That's it. So what is the value coming out to be? 4 into 10 to the power minus 7 newtons along the AB direction, which is I cap. You can also write it as 0.4 micronewtons, the I cap direction. And if you go back and check the direction of this, what is the direction of this? Both of them are acting upwards. That's minus. I hope you understood this. Now for the final one, part C. I will not solve this problem using any calculation. I will just use the concept of F net is equal to 0 on all wires. Because this is a very important concept, you have to keep reminding. So force on C will be plus force on A plus force on B is equal to 0. So from this directly I'll write force on C will be equal to minus of force on A plus force on plus. Minus of force on A कितना था? Force on A was 0.4 micronewtons I cap. 0.4 micronewton I cap plus 3.6 minus I cap. This is coming out to be minus minus है तो minus of minus ये कितना हो जाएगा 3.2 I cap forces. So this is a wonderful method, guys. I hope you understood this. So force on. So let's solve this very important problem. This is a very interesting problem. I hope you understand this problem. So let's solve this problem slowly. Now one thing we know. यहाँ पे I2 है. Current is flowing in anti-clockwise direction as shown in this figure here. So how do we solve this problem? कैसे? So one thing we know. The direction of field will be inwards here. The entire magnetic field will be inwards. So one thing we know, this wire and this wire, I2, the entire wire BC. So force total will be equal to force on AB plus force on BC plus force on CD plus force on. Now first tell me, will this be equal to 0? One thing I want you guys to imagine is, will this be equal to 0? A closed loop है. But one thing, the force total is not equal to 0 because magnetic field is varying. It is not constant. Magnetic field is varying. I think F total will not be equal to 0. So we have to check where magnetic field is varying and how it is varying. So one thing एक बार देख सकते हैं, force on BC and force on AD, if you observe, they both are along same direction. So they both have along same direction, same separation. They are identically separated from the wire. Producing the magnetic field. But the direction of current is opposite. Direction of current, every element if you see, यहाँ पे एक DL element ले लो, यहाँ पे एक DL element ले लो. At same distance, both of them will have opposite DL element. And symmetric. तो इससे मैं क्या कर दूंगा? I will say force due to BC will be equal to minus of force due to AD. तो इससे क्या आ जाएगा? So now F total now can be written as so from this F total can be written as FAB plus FCD only. The other two are getting cancelled. Simple. Now we have to find out the the force due to each individual wire of AB and BC. So this is the diagram given here. So this diagram ko let's take this diagram and see if we can take this. Can take this. So this is the diagram here. So force on AB and force on BC is all we want. Direction of current here is I1. So one thing we know, this will get attracted and this will get repelled. And so logically dekh lo, theek hai? I won't tell anything else. I will tell logically. Force due to AB will be towards wire I1. Hello Gaurav Kumar, I'm good man. And force due to DC will be towards away from I1. So isse we can say, and we know, and if AB is closer than DC, and we know it's proportional to 1 by D. So force AB will be greater than force DC. So it's simply CD, not DC. So from this simply I will say F net will be equal to FAB minus FCD. The direction towards what? Which implies FAB कितना है? आप simply answer लिख दो. FAB we already derived it already. It's equal to I1 I0 I1 I2 by 2 pi And what is the length of the wire? This is force per unit length. So the length of the wire will also be equal to B. So इससे ये आंसर आ जाएगा force total. And similarly force on CD total length B will be equal to mu naught I1 I2 by 2 pi D into 2 pi D नहीं है, ये separation कितना है? Separation initially was A and this one separation is A plus B. तो इन दोनों को subtract कर दो, कितना आएगा? Net force acting will be equal to mu naught I1 I2 by 2 pi into B भी ऊपर ले लिए, 1 by A minus 1 by A plus B is giving out to be mu naught I1 I2 into B by 2 pi into B by A into A plus B. इससे क्या आ जाएगा? mu naught I1 I2 B square by 2 pi into A plus B. So this is the total force on a current carrying loop, guys. मतलब loop placed in variable magnet. So I hope you understood this. Gaurav, you are a little late for the class today. The class is done. So adios amigos. This is the class for today. So this is a special channel. Let's crack JEE in English for those guys who need help in English. This is only for English special channel. There is no Hindi here. So matlab that's how it is. So share this video everywhere. Definitely like this video. Share this. Subscribe to the channel. Use the code NSS1 and come hit the comment section whenever you want to with any doubt you have. All right. So hit the bell icon for more notifications. Don't forget. So that's all for today, guys. Until next time, that is tomorrow. See you. Adios, amigos.